So it's probably worth starting off by just explaining a bit about the group that puts together the radar. It's a group called the Technology Advisory Board who put the radar together. We're a group of about 20 people made up of the heads of technology for all the regions globally. And really, it's a sort of group that advises our CTO on technology strategy. And then about 6-7 years ago, I think, we put together the radar as an internal thing. Now, the interesting thing about the group is, I mean, as we've grown, we're about 3,500 people globally now. I think 30 plus offices. Clearly, our CTO needs some advice, and that's the kind of group that gives the advice. The next thing is, radar is really about our experiences on our projects. So it's not a sort of extensive piece of market research about every single piece of technology out there, or where we've chosen a particular tool or technique or technology, we haven't gone off and said, we'll explore every single tool in this space. So what we've done is, we've used a particular tool, we like it, or we're excited about something, or technique or platform or language, and that's how it gets on the radar. The other thing, no money changes hands. This is the other question we get. Lots of people phone us up and say, hey, we've got this really cool new product. How do we get this really cool new product onto your technical radar, or your technology radar? And really, it's not about that. The only way to get it on to the radar is for our teams to be using it and to be excited about it. That's pretty much it. It's also opinionated. So the group of people who put this together, and Ian will talk in a moment about how that happens, but the group of people who put this together have very strong opinions about what they're interested in, different areas of technology, and their experiences, and that all comes together in the radar. So if there are questions about, well, maybe this particular thing isn't represented, that's often a consequence of there not being representation in the room or something else. Yeah.
Thanks, James. So I'm going to tell you a little bit about how we put the radar together. So it's normally every 6 months we have what we call our technology advisory board face-to-face. And anyone who's worked with ThoughtWorks will be unsurprised to hear that involves putting an awful lot of stickies up on the wall. And what happens is, prior to the meeting, each of the members of the tab, they gather input from their region, from the projects they're involved in, and that's from all around the globe. And then we come to the meeting and we get them all up on the wall. And then we have a process that we go through to distill that down, because we'll have like 300 plus new things, and clearly we can't fit 300 new things onto the radar every time. So we have a process we go through to try and distill that down into the few that actually make it on. And we've had quite a lot of people ask us about that, and could they do a tech radar themselves. We've had some clients do this, and they haven't used the same quadrants or the same rings, which we'll come on and describe what those are, as us. So what's happened then, Neil Ford, who some of you may have heard of, he's actually done a video describing how we put the radar together. So if after this you think, oh, that might be something useful for us to do inside of our organization, you can find that video of Neil, and he takes you through basically the process that we use to put the radar together. Okay, so the next thing I'm going to explain is basically the structure of the radar itself. So basically what have we got is the 4 quadrants. So we've got our techniques, platforms, tools, languages, and frameworks. And I'm sure it will come up later on, but sometimes it's not always clear exactly where something should go. Is this a tool? Is it a technique? Is it a platform? But we try and put them into these 4 different quadrants. And then what we have is these rings, and it's the radar metaphor, if you like. So what we have, second one in, we'll come back to the outer one, but the second one is assess. So assess is something that we're excited and interested about. This is something that we think you should be perhaps having a look at, and certainly we inside of ThoughtWorks are having a look at that technology, keeping an eye on it, seeing how it develops, thinking, is this something that maybe in the future could move further in? And the next step we have in is trial. So trial, what we're saying here is try it out on a project. Not suddenly, because sometimes companies, when they adopt new technology, they adopt it by buying something new tool and then suddenly telling every single project in the entire company they have to now use this new technology. What we suggest instead is try it out, do a trial, because it may work really great for company X or Y, but is it going to work for you? Well, try it out on a project. And there's also another important distinction we make in the move from assess to trial. So we have a rule that basically says, unless we have used it ourselves in ThoughtWorks and it's in production, we will not move something from assess to trial. Because sometimes people say to us, why is this really great tool not only in assess? Why haven't you moved it into trial? It's because we haven't used it. I think that's really important because we want the radar to reflect real things that we're actually using on projects. It's not an academic exercise, if you like. It's not a survey where we try and score stuff. It's what is the feedback from people using this stuff on our projects. That's primarily what drives it. So that's really important distinction. If it's inside of trial, if it's in trial or adopt, we've used it. And then finally we've got adopt. And adopt is basically saying, for the sort of problem space this tool, technique, etc. is good for, we think you should just be using this. We think you should just get on and use it. And in fact, internally, we have a little rule, we call it Mason's razor, which is, if I met another person from a ThoughtWorks project and they weren't using this tool to solve a particular problem, we might poke a bit of fun. We might mock them in the pub over a pint, saying, why on earth are you not using this tool because it's that great? So that's a little test we had, Would we poke some fun in the pub if someone wasn't using this tool? Now, the other thing that happens with the radar is things do move around, and on the printed copy, and it's maybe a little hard to see on this slide, but there's different shapes. So the triangles, one is triangles are new or moved. So basically, something's happened. So it might be new on the radar, or something significant has happened with that technology, and we've decided perhaps to move it from assess to trial. But also, we don't always get it right. Sometimes things will move out again, and we'll always say why. We'll say, actually, we thought this was great, but the direction that tool is going in now and some of the feedback we're getting from our projects, we just want to flag, actually, we've learned something new here, and we put that all out there, which sometimes can make us a little unpopular. So I've missed one important ring out, but I'm going to let James tell you about that one.
That's the hold ring, which is the one on the outside. It's worth calling out that it's got two different meanings for us. So we use hold to say kind of avoid. So in the sense of maybe stored procedures, logic in stored procedures in databases. This is something we've seen so much, and it's caused so much pain to a lot of the projects we've seen it used on, or organizations we've seen it in, that we just want to say, look, don't be doing this. The other meaning is the jury's kind of out on this. It's kind of cool, kind of exciting, but we're kind of a little worried about how this is going to pan out. And a good example of that might be Dart, say, the language, right? So we were a little unsure as to whether that was going to reignite a set of browser wars, or were we going to get some kind of cross-browser compatibility problems. So we had that in hold. So those are the two sort of separate meanings. Generally, we use it to mean avoid, has to be said. And we've got some interesting ones coming up in the next radar, which maybe I'll talk about later, maybe. But yeah, it's worth keeping that in mind. There's also a website now, so we've put up a website. It's quite helpful because it answers the question, why isn't this X cool technology on the radar, or why isn't this in adopt? Often what happens is after maybe two 6-month periods on the radar, something will fade off because we have to make space for other things, right? So things will fade off. But on the website, you can actually go and have a look at the historical blips. So if you think, oh, why on earth isn't closure in adopt? Because that's like awesome. It was. It's just faded off after two times. So that's pretty much that. I think it's maybe worth explaining, just before we go on to that slide, the format.
Yeah, so what we're going to do, obviously you'll be relieved to hear we're not going to talk about every single blip on the radar. So what we're going to do is go quadrant by quadrant, and then James and I are just going to talk about a couple of blips that we're especially interested in. So we'll kick off with the first quadrant we've got, which is technology. So the first one I'm going to talk about is number 17, which is an append-only data store. Now, the reason I'm calling this out is because of some work we did on a project with Clojure. And Clojure has this idea of immutable data structures. And what we found with the particular domain we were working in, where we had to record a series of actions that were being done as someone went through quite a complex application and assessment process. What we wanted to do was just always record who was the last person to touch this and do something on it. So we're just always appending to that data. And it was quite a nice pattern to take what was being expressed in the code and then store that using that same sort of pattern in the database. So it sounds a little bit obvious, but the other reason I'm really interested in this one is one of the things we see a lot of software projects do is they choose one persistence mechanism, quite often it's a relational database, and they use that for every single sort of thing they need to store. And actually, sometimes we need to think differently about the sorts of things we need to store. For example, one of the things we need to do is quite often we have to persist some state. As we go along, we need to record certain things. So, if we turn the power off or turn the power back on again, or somebody came away and came back, they're able to continue with what they were doing, or their history or whatever is still available. So that's one way in software that we need is to persist some state. The other thing we often have to do some reporting. Might be someone at the end of the month says, how many people did this, how many people did that? Let's generate a report at the end of the month. And quite often what we do is try and use the same things that we're persisting for state to generate reports from. And what we see is that projects you're getting conflicting patterns happening around how the code is using data, but you also actually have quite different performance criteria on some of this data. But we try and solve it all with one single persistence mechanism. And people often talk about the impedance mismatch of tools like Hibernate, etc. So I think what's really useful while like this one is think about why you're persisting the data and then choose the storage mechanism to match that, instead of choosing the storage mechanism and then saying everything has to go there no matter what.
So the first one I'm going to talk about is actually number 1 in Adopt. So this is a focus on mean time to recovery. Which sounds kind of obvious, right? We want to be able to recover from a failure as quickly as possible. But this has been a big shift, actually, for me, I think, recently in our industry. Traditionally, we tend to talk a lot about mean time between failures or mean time to failure. But actually, as some of the techniques we'll be talking about in a bit maybe have become more popular, things like containerization, things like the cloud, compute on demand, programmable infrastructure, building more distributed systems, so building maybe microservices-based systems. This focus on mean time to recovery has become much, much, much more important. The reason being, you've got more complex stuff out there, and if you don't know if these things are failing within a reasonable amount of time, then you need to kind of look at the tools and look at the practices you've got in place around things like monitoring. As an example, so Adrian Cockcroft at Netflix and the sort of Netflix platform teams, they talk about knowing whether a particular process or instance has failed within 5 seconds. They want telemetry that will tell them within 5 seconds whether something has failed or not. And that's a real shift. This is not your users phoning you up and saying, "Hang on, something's failed." This is not maybe some alerts going off somewhere. This is being able to have live telemetry that tells you within 5 seconds that something has gone down. In order to do that, there's some interesting shifts, I think, going on. So the first one is, I'm going to be a bit controversial here, but a move away from integration testing, a move away from trying to prevent failure and put processes in place to prevent failure with things like integration testing up front, and a move towards things like semantic monitoring, a move towards things like running synthetic transactions through your system. And actually, the most interesting thing for me is this idea of identifying invariants in your telemetry and monitoring them, because they can give you a really, really quick way of identifying failure in a distributed system. An example of that would be the invariant between, say, you have one process that takes a message in and produces 3 messages out the back. There's an invariant which is the number of messages in to the number out. If it suddenly starts only producing 1 message, then you can monitor that, and really quickly it'll give you, it's an invariant, and you can really quickly get an idea that something's going wrong within your distributed system.
Okay, cool. So the next one I was going to talk about is number 27, for those of you following on the paper copy, which is security sandwich, which sounds a little bit odd. So I'll try and describe it, but it's really trying to describe how projects tend to interact with security folks. And the way this often seems to happen is we'll come up with a project plan, whether that's a bunch of stories or whatever it might be, and then we'll engage with someone from the security team, and they'll come and give us their view. Is this the right thing? Are we doing the right? Have we got the right requirements captured from a security perspective? And then what tends to happen is they go away. And then we spend a bunch of time delivering and working on and software. And then they come back at the end and we might do some pen testing and they might give us some forms to fill out so we can go live. And the challenge we're seeing is that we've got them at the beginning and then there's a bunch of stuff in the middle and then they're there again at the end. So hence the sandwich image. Now the thing we're seeing is actually, if you look at a lot of the practices and the way teams work over time, what we've actually been doing is bringing them in to be part of delivery. So instead of the BAs just writing a requirements document and throwing it over the fence to the developers, the BAs are actually sat with the developers and working with them. And the same with the testers and on our projects as well. Same with the DBAs. You know, if there's a developer as part of my story that I'm working on, I have to write some SQL, then maybe I can pair with the DBA on that. So the idea here is security sandwich, we put it on hold. Actually, doing that is better than nothing. And I think we're all too often reading in the paper around companies who perhaps have done nothing about security. They haven't thought about it at all. But what would be even better is to try and persuade the security people to come and engage with your projects on a more regular basis. Maybe they come to the stand-up once a week, or maybe if you're working on something that's about security specifically, you get them to come and pair with you and look at what you're doing to get that feedback immediately. Because the thing we know is that the cheapest time to fix a problem is just after you've created it. If we leave it all to the end and we get a few surprises or whatever, that might be due to some code somebody checked in 3 months ago. And that's much harder to diagnose. So that's the idea of security sandwich.
I think there's another interesting thing there. You talk about how the way we're working these days with things like continuous delivery, build pipelines, all these sorts of things becoming, well, kind of de facto kind of standard on most teams I work with generally. Doing things like bringing automated security tooling into your pipelines, right? That's an awesome approach. So, you know, it's not going to solve all your problems in the same way that, you know, running simple performance tests as part of your build pipeline won't fix all your performance issues. But at least it will alert you if a set of maybe simplistic things are going wrong. So, you know, tooling won't fix this problem, but it can help. And we've got a team in China, I believe, who I think they've set the goal that every single project they run, and you know, there's 600-700 people, developers in China. There's quite a few projects they're running. Every single build pipeline has automated security sort of penetration testing stuff running as part of it. That shouldn't be strange, but I'm not sure how many people in this room would say that they have that stuff in. In fact, I might ask the question: who's doing that? Who's running automated pen testing as part of their builds? So 2, 1.5, 2.5. So yeah.
If everyone else could just write the URL of their site down on the way out.
So the next thing I'm going to talk about is something that's on hold, and this is Microservice Envy, which is maybe, is it controversial? I don't know, given that there's so much hype about microservices at the moment, and I think I sort of consider myself in some ways the grumpy uncle of microservices. It seems strange that we'd put Microservices Envy on hold. What we mean by that is, this is a style of building systems that's suited in only particular places, right? It's not suited everywhere. And the danger we see, or the things we're seeing as the industry suddenly jumps on board this, is that everything is going to be hit with the microservices golden hammer. Now, there are many good things you can get from decomposing your systems into smaller services, right? But also there are lots of challenges you have to face along the way doing that. So what we're saying is, you should be aware if you're thinking about building out a microservices architecture that, it might not necessarily be suited. So examples might be because your organizational structure isn't set up to handle the kind of distributed system in microservices. It might be that your ops team or your operational capability isn't mature enough because you get a lot of additional operational complexity with microservices. It might be that you're a startup, right, and you want to get something out to market really, really quickly. Now, there is an overhead in building out microservices. There's an undeniable kind of runway you need to go down before you're going to be able to build, to get the benefits of a microservices architecture. If you want to get a product out quickly, into the market quickly, it's not necessarily maybe the right choice. So I guess what we're saying with that is, we're seeing lots of success from organizations all over the world, really big ones, really small ones. But the ones we're seeing more and more that are very successful, fall into the category of people who understand their domain and who are maybe building or refactoring or strangling an existing big monolith that's hard to change towards a microservices architecture. So what we're calling out with microservices on hold is, be careful. This is not Envy. Sorry, microservices. Yes, it's not microservices on hold. Microservices Envy on hold is that be careful because there may be dragons. Yeah.
And I guess a little bit, probably what we're thinking is perhaps some of what happened around SOA, where just it seemed like almost every product and everybody was using SOA and perhaps not always stopping to think, is this actually the right solution for me, for the domain I'm in and the problem I need to solve?
So on to tools.
Cool. So hopefully we'll get more hands on last night. How many people are doing Clojure development?
No, same
number of hands as last night. Oh, okay. So,
2.
But Cursive is something that works with IntelliJ. If you're doing Clojure development, it can give you a lot of the benefits of an IDE when you're doing Clojure. I know some people that say, real programmers only use Vi and Emacs. But what we're seeing is if you're trying to do large-scale adoption especially, then having the tools to support people and help people while they're coming up to speed with a new language is actually really quite important. And if they're already familiar with something like IntelliJ, that can be quite a nice way, rather than just saying, right, throw all that nice stuff away and just use Emacs like me, because I'm a real Lisp developer. So that's one of the reasons calling Cursive out, but I guess there's not that many people doing Clojure. Are you using IntelliJ or Cursive? Okay, so I've just told 2 people in the room something they already knew. Great. But if you haven't checked out Clojure, I do recommend. I don't know about you, but I've always got a list of what's the next language I should go and have a play with. And Clojure, I think, is really interesting. There's a lot of really great stuff happening in that area. So if you're thinking, what would be a good next language to go and have a look at, maybe Clojure is the one. Cool.
So the first thing in this quadrant I'm going to talk about is, it's probably the theme of QCon London, which has happened about 3 weeks ago or 2 weeks ago, more or less the theme, which was Docker. There was a track on it. Everyone was talking about Docker and containers. Not necessarily Docker. There's now an entire ecosystem around Docker. There are projects around how to manage the management of Docker and all this. It's kind of crazy. But I mean, it's really exciting. And so for those of you who haven't come across Docker yet or containerization, essentially it's a way of creating very, very small kind of deployable, quote, containers that you can push into lots of different operating systems and sort of drop in with your application, and they'll kind of run. Essentially, they provide sort of process isolation, sort of CPU pinning, and all these sorts of things, and in a very, very lightweight way, like LXC does as well. And a lot of it's built on either LXC or other virtualization libraries. Sounds very dry and boring. As a developer, and you wouldn't believe it, but I spend most of my time writing code generally. I've noticed this shift over the years, right? So, first of all, what we used to do is, we used to create, when we were maybe in Java, we'd write some code, create an app, web app, and we'd deploy something, we deploy it into Tomcat or into JBoss, or if we were really unlucky, into WebFear, whatever it was, right? We've moved away from that a bit now to packaging things as maybe their own executables. So if it's Java, you might have a one-jarred up or uberjarred application, which you just execute, and it contains a web server within it, and you'd put that onto a machine. Now, then we sort of moved on to this idea of, right, we'll package these things up as RPMs, and then the last project thing I was on all of last year, we moved on to the idea of creating things like Amazon machine images. So we'll create an entire operating system stack as an image, and we'll just like slap up one of these little RPMs. We'll slap an RPM with our executable in it, and that's our deployable unit. That's great, and it kind of helps you with things like Phoenix servers and sort of Phoenix environments and those sorts of patterns. But it does come with some drawbacks because your build times blow out, essentially. So the feedback as a developer starts to get a bit longer when you're having to create big things like AMIs. So for me, the nice thing with containers is it's much, much quicker to create them. So I can create these really self-contained, portable, deployable units containing everything I need to run an app as the end result of my build pipeline and install it and run it somewhere. And Docker gives you that. The other nice thing I like about it is it's a sort of, I wouldn't say the final nail, but it's the penultimate nail in the coffin of, kind of it works on my machine. All right, we've all come across this. It's fine. I'm developing on Windows. I'm going to deploy onto RHEL. But it worked on my Windows, 9 kind of operating system. Why is it not working on the Red Hat Enterprise? That kind of it works on my machine problem that everyone always gets. And it means that you can actually start up lots of these containers locally in a VM. So you can actually do much more in the ways of testing and all these sorts of things locally as a developer. And that sort of, for me, is really good because you get much, much, much faster feedback. So,
cool.
Yeah. We used to use Vagrant to do the same thing. Obviously, Vagrant's a little bit heavier, but yeah.
Cool. So the next one I was going to call out, and always difficult with tools, but I was going to just mention really quickly GitLab. Just really interested, how many people are using Git for their own personal projects? Okay, cool. Keep your hands up if you also use it at work. Okay, there's still quite a lot. Okay, so one of the things we're seeing and we still run into quite often is you get people who are using Git for their own personal projects, but at work, they're having to use something else, and something that actually is getting in the way of their productivity and not letting them do some of the things they've got used to doing, quite often by using GitHub. So GitLab is one solution. It's not the only way to do this, but this is one solution for setting something up that is within the company that you have more control over and allowing people to use Git internally. Now, you may say, why not use GitHub? Well, there's a couple of reasons. Sometimes what we've seen is people are checking in, for example, test data into GitHub, and that data might contain something that shouldn't be exported outside the EU, for example, or probably is confidential and it shouldn't be. So you want to have that test data under source control because that's good practice, but perhaps people aren't always aware of the implications of putting something into something like GitHub. And then the other thing we're seeing an awful lot, I guess a lot of people have maybe heard about this already, is there's people now who are actively mining GitHub for credentials, for passwords, things like that. And actually the big one at the moment, a lot of people, who's heard about the AWS things happening with credentials being, okay, not that many people. So this is really interesting. There's basically, let's call them what they are, there's a bunch of criminals out there, and what they've done is created this tool that scans GitHub. And what it does is finds people who've checked in their Amazon credentials. So this is the API secret and the key. And then they take those and they automatically use those stolen credentials to create a whole bunch of instances, big like M2s, expensive, big compute instances inside of AWS, and then they Bitcoin mine. And they basically make a bunch of money by doing it. And normally what happens is Amazon pick up the phone and say, hello, so-and-so, we just noticed that you've gone from free T2s to last night you were running 100M. What's going on? You get that unwelcome call from Amazon because your credentials have been compromised. And I'm sure there's other things that happen. I think people have managed to check in their private keys because they just haven't thought through the implications of using something like GitHub. So it's just, I guess, two things. One is possible solution if you want something inside the corporation, but also as well, watch out for what you think about things like GitHub. That's a resource that's out there, and there are people looking basically to steal your credentials if you're not very careful. Okay, cool.
I'm sure that he made a great joke, well, rather poked fun at me for being a corporate Git last night. So,
yeah. I didn't even mean to do that. Sorry.
You didn't get it in tonight. It's a shame. We were in Manchester last night. We're on tour. So the next thing I'm going to talk about is something called console.io. And this is I believe it's in assess, but we've just moved it up to trial in the most recent radar. So this is, where is it? 72, this is. Console. So console's quite fun because it kind of solves a bunch of problems that you don't necessarily know you're going to have when you start off trying to build maybe a microservices architecture or building an architecture composed of lots of small interacting services. So it does a bunch of stuff. So it does service discovery, it'll do health checks, It does things like service registration. It provides a key value store. So if you've come across Zookeeper, it provides a key value store like Zookeeper, so you can put configuration into it, and you can kind of suck that out. But the nice things about it is, as I say, it solves some problems that you only they're almost like higher order problems around distributed systems. So things such as if you're creating Phoenix servers, so Phoenix instances as opposed to long-lived servers, or this, which is a pretty common technique these days. So Phoenix server, if you haven't come across it, is a server that, an instance maybe on Amazon, that you'll start and it will run for a bit, and then you'll terminate it, and rather than upgrade it, you'll start a new one. So it's like it's almost like an append-only infrastructure in some ways. You only ever create new instances and delete old ones rather than upgrading your current infrastructure. Kind of interesting idea. Now, that's really useful and really handy. It's a great pattern to use if you're doing continuous delivery and continuous deployment in the cloud. But the problem is many of the tools that are sort of exist in the space around monitoring, sort of telemetry, these kinds of tools, they don't like the idea of these really short-lived, maybe even hours, servers that live for only like a couple of hours at a time, potentially, or maybe a day at a time. Most of the tooling is built around the idea that you'll have long-lived groups of servers that you upgrade and you can install agents on and things. So what Consul does is it kind of handles a lot of the problems you get. So, for example, it does service discovery. It does this via DNS. So it's a DNS server, which is quite funky. Right? So if I start a server up, I need to talk to another server. I need to talk to Ian. Potentially, how do I know if Ian's there, what his address is? What Consul allows me to do is to issue a DNS query to say, give me all the Ian servers in this kind of zone, and it'll come back with a list of IPs that allows me to address Ian as service records. So that's quite nice. It's also really high availability. So it uses a what's it called, Raft, I think, the consensus protocol is a bit like, it's a flavor of Paxos, and then uses a gossip protocol to communicate changes between them, so between nodes. So it's actually pretty cool. It also ties in quite nicely with things like having application status pages, which we've had on the radar before. So we're firm believers that every single application you have should have a well-known URI that you can go to, where it'll tell you the status of that app. So am I up, am I down? What are the statuses of my external endpoints, say? How many requests am I processing at the moment? And it works quite nicely because it can health check on those status pages and report back to a really nice, shiny central console. So if you're looking for some kind of service discovery tool, Consul is well worth a look. We moved it to trial because we're now using it on projects in production, and we're very happy with it. Yeah.
Okay, cool. So we'll move on to the next quadrant. Okay, so the next one we have is platforms. And the first one I'm going to call out is number 45, SDN, so software-defined networking. And I've become very interested in this because of some work we've been doing with VPCs and Amazon infrastructure. And this ability basically not just to, if you like, the instance problem is solved. We can spin up an instance and get software on it really quickly. But what we can do inside of Amazon with VPCs and things like CloudFormation is I can also define my load balancers and my subnets and my routing rules and my access control lists and my security groups. So I can actually define not just my instances that I want, I can define a whole infrastructure, basically declaratively, so in software if you like, and then I can just say, right, give me one of these environments, please, and that will spin that environment up. And one of the things we've seen where we have done this, if someone says, right, we need another environment, perhaps instead of Europe, we want that in one of the US regions. Well, if you've scripted all of this stuff, you can just run it up over there. But the other reason I'm really interested in this is, I said that quite often the instance problem is solved. If we want to get hold of a new machine, if you go back far enough, actually that was a major undertaking. Someone would have to go to the procurement department, they would order some hardware, at some point the hardware would turn up at the data center or your machine room, someone would have to rack it up. And so actually we don't have that problem anymore. Hopefully, if we're using things like VMware or in the cloud, we can say, give me another instance, ta-da, here's an instance, and off we go. But what we're seeing on some of our projects, we've moved on, if you like, to the next bottleneck. And the next bottleneck is, oh, hold on, that server can't talk to the DB server. Or it's talking to the QA one instead of the UAT one. And the firewall isn't configured properly and the packets aren't getting through. Or the routing rules are incorrect. Or we haven't tested it with the load balancer and nobody remembers how to configure the load balancer because the person who did that has left the company. So I asked the question last night. It'd be interesting to ask it again. So for those of you who've got load balancers out there, how many of you got of all of that config and that the things you need to configure your load balancer checked in? So if you needed to, you could just recreate that. OK, 2 people, maybe 3 people. So actually, that's another thing that we keep hearing in terms of who looks after this infrastructure. We're still in a situation where we've got a small number of very specialist individuals who understand that. And if they leave the business or if they're unavailable, that can actually be quite a bottleneck and a risk. So that's the reason I'm particularly interested in the whole area of software-defined networks. It's in assess, so we're saying it's one to watch. We're not saying start doing these yet, but I think it's a really interesting one to keep an eye on, and maybe in future radars it might move further in. Cool.
So I want to talk about, for me, I'm going to talk about event store. So Ian was talking about append-only data stores earlier, and there's a number of different, patterns you can apply to get append-only data stores. There's also products you can use. So example would be, most financial institutions would be familiar with the idea of append-only data stores because that's just basically how you do intraday and interday calculations, right? You store price changes and things over a period of time, and then intraday is like reading up to a point, and end of days is reading up the whole thing for the day. That's just how we've done that stuff for a long time. But now you've got tools like Datomic, so quite familiar in the closure world, which provides you. They call it almost like a read-only database in some ways. So you can never actually change the state of any values in your database. You can only add state, which is kind of interesting. Event Store is another kind of tool. It's probably more familiar to people from the .NET ecosystem because it's from a guy called Greg Young, who's more famous for the CQRS pattern, so command query responsibility segregation. What I quite like about Event Store is it provides the ability to, it's an append-only data store, so you get data stored as a series of events. But also, it then exposes those events as feeds, which you can, if you're another application, just subscribe to pretty easily. And actually, it's a bit like OData or Atom, the format for Event Store, written in JavaScript, and it's quite nice. Pretty high availability apparently, pretty performant. They've benchmarked it to about 15,000 writes per second. So if you're in the space where you're looking at doing event sourcing, you're looking at append-only data stores, it might be interesting to have a look at Event Store. It's in append because I don't think we have it in production yet. I know of 2 projects that are using it, but I don't think they're in production yet.
Cool. So the next one for me on platforms is TOTP, two-factor authentication. And I can never get it right, but it's basically a time-based protocol for two-factor authentication. Previously, the barrier to two-factor authentication has actually been really quite high. So you might have a key fob with a number on it that rotates around, and you have to have some specialist hardware in your data center to work with that key fob. Or you might have one of these things from your bank where you put a number in, and it gives you a PIN that you put in addition to your username and password. So actually, people have viewed the barrier to two-factor authentication as being high. But what's really interesting about this is it actually lowers the barrier a bit because you can get things like the Google Authenticator app that you run on your phone. And basically what you can do is then generate a token, if you like, for your site that you can load up into the Google Authentication app. And then using some software, you can basically then, when somebody comes to your site, you can do the two-factor authentication piece. So I'm interested because I think security more and more is becoming more and more of an issue. I think if you look at some of the information we're storing about people, the loss of someone's password, especially if they've got the same password on every site, could be fairly catastrophic. And this is one way, depending on your customers and the sort of data, that you could try and address that problem.
I was talking about this earlier to someone. It's quite common, I find, to talk with product managers, and they're really, one of their major concerns is we don't want to put barriers in front of people, in front of the users of our software, of our site. Right? We don't want to put some really clunky process in that stops people coming into our booking or sales funnel or whatever it is. And I like this because it is really simple. It's an open standard. It's not proprietary. You don't have to go off and do tons of really hard integration work. It's a low barrier to entry. Maybe it can help us have some of those conversations before the horrible conversation of, yeah, sorry, someone stole all the passwords again, or whatever it is.
And there have been some incidents where passwords have been stolen, usernames, password. If they'd had two-factor authentication, it's an embarrassing conversation to have with your users, but their account is not compromised at that point. Just coming back, I was talking about Amazon security earlier on. I was wondering, those of you using AWS, have you got two-factor authentication enabled on? Okay, lots of nodding. Okay, good, because that is another one that's caught a few people out. And it wasn't there right at the beginning, so if you haven't got it, go and enable two-factor authentication on your accounts in Amazon. And that will actually work with this Google Authenticator app. And so basically when you log on, you just call up get the number up on your phone and tap that in.
So there's another one related to that, which is UTF.
Which I managed to forget last night as well. Yes.
So UTF is kind of another two-factor protocol, if you like, but it's hardware-based. But it's based on really inexpensive USB keys, sticks, essentially, that you just kind of plug into the side of your laptop. Again, it's an open standard, championed by a bunch of people, I think, including Google. So it's another option, and it's almost like a greater level of security because keys aren't sent flying. You have a key stored on the device, and there's never any exchange of secrets between you and any services. So it's all local. But it's another thing, and it's quite interesting that a lot of these are now becoming really accessible and easy to develop against. So.
Cool.
So the one I'm going to talk about is number 42, which is the Netflix open source full stack in Assess. So this is kind of an interesting, I don't know if people have come across the Netflix open source stack. It's got everything, including the kitchen sink in it, essentially. So what they've done is they've harvested a bunch of great ideas from their platform over time, and then they've open sourced those as sort of libraries and products and so on. So it might be across the monitoring space. It's like their HTTP clients they use, the Cassandra binding or clients they use to talk to, the data stores. All this stuff is now open sourced and we can all use and actually submit pull requests and Fall can submit pull requests to, which is fantastic. What we're also seeing, which is maybe slightly odd, is this idea that actually what we're going to do is use the whole thing. We'll just like download all of Netflix and we'll build our site using all of Netflix. Now that sounds like a great idea because you get all this stuff and it's really well built, really well engineered. But at the same time, most of us aren't streaming video companies. And the thing about Netflix is they've built a lot of stuff for that make a streaming video company work. So whilst there's lots of really cool stuff in here, maybe pick and choose and don't just go, well, we'll have everything. I'm actually quite passionate about, and this is a weird thing to be passionate about, but I'm actually a little bit passionate about some of the libraries in this. So there's the circuit breaker library called Hystrix. People have come across that. Hystrix dashboard, Turbine, which is the stream library. Now Hystrix is fantastic because it allows you to do, well, it's an implementation of circuit breaker and bulkhead from Release It, the book. And it just makes your software so much more robust. We were using it on a project well, it's still ongoing, but last time I was on it was last year, and it was awesome. And it enabled us to have interesting conversations about things like eventual consistency and about availability with our business stakeholders. Because essentially what Hystrix will let you do is put timeouts on calls to external services. So in our case, we had we wanted to authenticate users coming into us, and we wanted to call off to another authentication service. But if it took too long a time for that call to return, we wanted to say, actually, we're going to just give you the content for free. And that was a nice conversation to be able to have with our business stakeholders. How long is it? Do you want to trade off a really long page load, or would you prefer to have a really short page load but give the content away for free? So this kind of enables nice conversations. The other cool thing is, and I think we've got security monkey somewhere, but is the chaos monkey group of, or the monkeys, the simian army as they call them. If you haven't used these, Chaos Monkey is probably the most famous. What Chaos Monkey allows you to do is effectively unleash carnage in your data center, potentially against your live data center. So we just had it running in production, and what it would do is every, I don't know, hour or so of the maybe 80 instances, 80 servers we had running, it would randomly kill a few in production. Through various nefarious kind of methods. So the most common one is it just turns them off. So that's, you have to start building systems that are reliable if you know that every now and again one of them will just go away. You have to think about how you scale single points of failure. There's another funny thing, which is this idea. It's got this one property called burn money equals true, which is awesome. And if you have burn money equals true on, then you can do things like randomly fill up all your hard drives, or just randomly flood your network with packets. And it'll just do this in your live infrastructure for you. Now, if you've got the confidence to be able to do that, then that gives, well, if you're able to do that, and you're able to withstand that sort of, I guess, that carnage, then it gives you a lot of confidence that actually you can put up with most things within your production environment. So, awesome stuff, Hystrix, the monkeys, etc. All of it, not so sure. Cool. Next up.
So, last quadrant, languages and frameworks. I mean, traditionally, this has been a slower moving quadrant for us, although I think perhaps in recent years that's changed. So the first one I'm going to call out is Swift. How many people here are doing iOS development? Cool. Not so many, but are any of you using Swift yet, or are you still Objective-C? Okay, so it looks like you're all... So I think we had Swift on further out a while back, but what we're seeing is, as a language, it's got a lot of features that perhaps we've got used to from other languages like Java and C#. So if you like, it's more modern in some of the language features it has. And that's actually helping people who aren't familiar with Objective-C. What we were seeing before is perhaps someone who knew Java, they were actually struggling. They were finding that quite a steep learning curve to come over into Objective-C, whereas with Swift, they're actually being able to get productive a lot more quickly, which is a great advantage. The other thing we've seen, I think early on, Xcode, I don't know if you guys ran into this, but Xcode just seemed to fall over. Yes, I can see some nodding heads. So there were some stability issues with Xcode around Swift. What we're hearing, certainly sort of ThoughtWorks, is that it's a lot better than it was. I don't know if it's gone away completely, but the tooling has improved. So we're actually saying, if you are thinking if you're actually thinking of doing Swift for, sorry, I'll try that again. If you're thinking of doing iOS development, maybe try out Swift on one of your projects. So again, we're not saying use Swift everywhere, throw all your Objective-C away. We're saying maybe it's one of those things you should try out, see how you get on with. Now, there is one thing, because one of our colleagues, he wrote a mocking tool that allows you to do mocking, which helps do unit tests in Objective-C. And he's frustrated because he can't make that work in Swift at the moment because there's no reflection in the language. So there are some things that aren't there yet, things that perhaps we are used to from other languages like Java and C#, but we haven't got them in Swift yet. So, but hopefully that will get addressed.
Okay, so I'm going to talk about dashing. So people have come across dashing before. Dashing is it's in trial, number 87. It's not a new programming language or anything exciting like that. But if you're like me and kind of into things like monitoring and telemetry and BI, showing business meaningful information and so on to both to developers and also to our kind of stakeholders. Dashing is really awesome for creating, well, I think it's called the exceptionally handsome dashboard framework. Right? It's really, really easy to create really good-looking, simple, elegant dashboards to show, I don't know, things like orders, number of orders per day, or orders received, or more technical things if you like. It's Sinatra-based, so pretty straightforward to set up, pretty straightforward to run. Comes with a bunch of nice widgets. So things like text widgets or graph widgets or all these different things that you might want to use, and it's kind of declarative. You write a little bit of Ruby, and it'll update the widgets. So it's really, really straightforward. And if you're in the space of looking for something that will do nice big visible dashboards for either your teams or for your business stakeholders, well worth having a look at. It's awesome.
Okay, cool. So the next one for me, I'm going to talk about Java 8 in Adopt. There's a couple of reasons for this. I don't know if anybody remembers, but for a while we actually had Java end of life in Assess. And we actually got some stick for that. But the reason we had that out there in Assess was we were getting really concerned about what was not happening with Java. We had this long period where really not much interesting happened with the Java language. And alongside it, we had things like C# and things like Scala and Clojure starting to emerge that were doing lots of new and interesting things. And so we were concerned. We were saying, maybe you need to be having a look. If you've got a lot of Java code, what's happening there? But that's changed now, and now we have Java 8 out there. How many people are doing Java and have moved to Java 8? Okay.
How many people are doing Java?
How many people are doing Java? Okay, so there's quite a few who haven't moved over yet. But we're finding there's some features in the language we really like. Won't run through them all, but just to call a couple of things out. For those of you who've done C# development and are familiar with Link, there's some really nice things in there that allow you to write terse but still quite readable and expressive code. And we've seen this ourselves, that when you go from C# back to Java, the previous version of Java, you suddenly think, my goodness, I've got to write an awful lot of code to do what was just as understandable, but it was only 2 or 3 lines. So this is about like using lambdas, for example. So, and again, it's this broader trend of functional features from functional languages finding their way back into things like Java and C#. So that's one thing we really like that's in the language. And the other one, just call out just one other thing about Java 8 is we really like the way the streams implementation has been done. I think it's very robust and it's highly performant as well. And actually, only a couple of weeks ago, I had an experience where we're having an issue with an out-of-memory issue where someone was loading in a huge amount of data in, all into memory in one go. Okay, yes, we can talk about whether that was a good idea afterwards, but by just changing a couple of things, very easily change that to use streams, and obviously then it wasn't loading the whole thing, it was just processing each record as it was read in. So and it was very performant, and the memory issue went away. So that's something else. So if you're not doing it already, we're actually at the point now, if you're doing Java and you've not got to Java 8 yet, we might poke a bit of fun at you in the pub.
And I think that was the end.
Yes.
So thank you all very much for coming. We'll be around now.